Hi, welcome to this session. In this session, we are going to talk about how to define matrices or create matrices in MATLAB. Then we are going to talk about how to define linear vectors in MATLAB, and also we'll talk about line space function, which is used for creating linearly spaced vectors. So let us start how to create matrices in MATLAB with an example. So I will give here some x label for the matrix as x equals 1 space 2 semicolon 3 space 4. So when I press enter, I am able to see that I am getting a 2 cross 2 matrix. So what I did here is I have just given two elements in row 1 and two elements in row 2. So how do we know that which elements they belong to row 1 and which elements they belong to row 2? So you can see there we have a separator, a semicolon. The semicolon separates the rows. So any element appears after the semicolon will be placed in the new row. So like this we can create a matrix of any size. So here I have just shown a matrix of size 2 cross 2. So let me create a matrix of size 3 cross 3. Let us say y equals okay. So now you can see that I have created a matrix of size 3 cross 3. So like this we can create a matrix of any size of our choice. Now let me show you how to create this matrices with other ways, or if you say like I have one dimensional vector, using that vector I need to create a two dimensional matrix. Example is our x. Already we have x. Let me clear the screen here. So I will say x here. Then I want to add one more row for this x. So what I can do is I can just use here x of third row. Actually there is no third row here. I will specify 3 comma and I will put the semicolon. Semicolon indicates all columns. Actually it's a type of row and column addressing I am using here. X of third row comma all columns. So I want to create a third row and all columns of that third row to be with some values. So I want that values to be equal to x of 1 comma colon. Now you can see here what I am doing is the first row of x I am just assigning to the third row of x. So this is how I can easily join or add an additional row of my choice. See, so I am able to add one additional row to the X matrix. Not only this, we can easily concatenate these matrices by using simple operators comma and semicolon. If we use comma, then we can join the matrices row wise. If we use semicolon, we can join the matrices in column wise. Let me show you the example for the same X matrix here. So I want to just create a new matrix x1, which is concatenation of matrix x. So what I will do is I will say x comma x. Now you can see here I am able to join x matrix row wise. So the same matrix x has been concatenated, joined one more time next to x, finally giving us a matrix of increased size in dimensions. Similarly, we can also join this column wise. So let us say x2 equals. So what I have to do is instead of using comma, I need to make use of semicolon. Okay. So now you can see I'm able to concatenate x in column wise direction. Okay. So this is how we can create the matrices. We can create one dimensional matrix. We can create two dimensional matrix. We can add the rows or we can delete the rows, or we can just concatenate the matrices row wise or column wise. So I will show you one more example how to delete the row so that we can move to the next topic. So let us say I want to delete last row, that is 1 2. You can see here for this matrix x2. So what I can do is I should know the position of that row, like which row and how many columns. Okay, so here actually we have two columns. So instead of specifying that, we can just make use of colon operator, which will take all columns into consideration. So let us say I want to delete this last row of this matrix x2. So what I can do is x2 of last. So I need to count here, like what is the position of the last row. You can see there we have 6 rows. I can say it is the 6th position, so I can use 6, or else I can also use one more uh, keyword like end. I can use end. By default it will go to the last row, so let us use 6 here. So I can say 6 comma colon. That means I need to delete that 6th row and all the column elements. So what I can do is equal to some empty square brackets. So now you can see that that last row has been deleted. So like this we can delete the rows or we can add the rows. Okay, we can just do anything with the matrices, creating, adding, deleting, etc., and of any size. Fine. So this is about matrix declarations, defining matrices. Now let us move on to the next topic, that is how to create linearly spaced vectors. See here we have one very important operator by name colon operator. Using this colon operator we can create a vector of our choice, a vector which is linearly spaced with the steps of our choice, maybe in the steps of 1 or in the steps of 2 or in the steps of 3. So let me show you one simple example here. Before that I will clear the screen. Let me clear this workspace by using this basic command clear. Okay, so see I'm going to create a linearly spaced vector. For that I will use some variable t here, t equals 1. I want to create a vector having values between 1 to 10 with a spacing of 1 or with the steps of 1. So I need to specify, first I need to use the colon operator, the starting index, the colon operator, and the steps value. I want the steps in the steps of 1 and then colon, and then I will specify the ending value. I want to generate a vector between 1 and 10 with a steps of 1 or with a gap of 1, interval of 1. Okay, let me see what we are getting. See, this is how it's very easy that we can create a vector of any size by just making use of this colon operator, by specifying the starting and ending index value, and then specifying the step value in between, like we want the values in what steps, whether in the steps of 1 or 2 or 3. So if I just change the step value from 1 to 2, you can see that I'm able to get the values between 1 to 10 but in the steps of 2. Okay, so this is how we can define a linearly spaced vector easily, of any size, of any step, between any interval. So we need to make use of this colon operator. So next we'll see a built-in function which is available in MATLAB, that is line space. Using this line space function also we can create a linearly spaced vector. So let me make use of that line space. Actually this is the name of that function, and we need to pass the arguments for this function, like I need to generate the values between what values and how many values. Let us say I want to generate values between 1 and 10, 1 comma 10, and how many values I want to generate. So here I can specify any number as per my choice. If I want to generate some 6 values, then you can see there I'm able to get 6 values, a vector of 6 values, and the starting and the ending index is between 1 and 10, what we have specified in the argument. Okay, so like this we can just specify the number of elements we need between that 1 and 10, and we are able to generate that vector. We are able to get that vector with the help of this built-in function line space. So what happens if I don't specify this 6 here, like I'm not specifying how many numbers it has to generate between 1 and 10. So there is some default value, like it is going to generate 100 numbers between 1 and 10. Okay, this is about today's session. So we'll be discussing the new things, the next upcoming topics in the next class. Thank you.